Hi, today we're going to talk about quadratic functions. Instead of having to pause this video, you can get the complete outline of these notes in our shared folder on Google Drive. If you're not sure how to get there, just pause this video and ask me, or you can always email me if you're not in class. Alright, quadratic function. First, we got to talk about the parent function. The parent function for quadratics is y equals x squared. That's our parent function. Remember, the parent is like the basis of all the functions that are quadratic. So all other quadratic functions, you have to maybe put a 2 in front of here, or maybe divide by 3, or add 4, or something. But all of them are like this, just changed a little. And that's going to look something like this on the graph. So that's my best drawing I can do of a quadratic function. Not the prettiest, but I think you get the idea there. Yeah, it looks good enough. When in doubt, you can just put it in your calculator and it'll give you a much better version. Well, let's think about domain and range. Remember Dixie-Royd, so domain is the x values. Well, we see that going to the left, this is going to go on forever and ever to the left. It looks like it might stop here, but really it goes on forever and ever. And going to the right, same thing. It's going to go on forever and ever. So that means our domain is x is in the set of all real numbers, because it goes forever and ever, both left and right. Okay, range is a little different. So range, that's going up and down. Our smallest point, it stops at the origin. So that means 0 is the smallest value y can be, but it goes up forever and ever. So that means y must be greater than or equal to 0. Alright, we've got a few ways to represent the quadratic functions. Alright, let's start with the equation. So in any quadratic equation, x must be squared. Has to. That can't be any other exponent. X must be squared. Y must be just by itself. So remember, I'm putting that 1 so that you know it cannot have any other exponent. But normally, when we have a variable to the first power, we don't bother writing that 1. So usually you'll just see y, nothing else. And it cannot have x in the denominator. So x cannot be in the bottom of any fraction. And a little note is if you see y squared, that's not a function at all. So if you see y squared and the question asks you, pick the function, it's not going to be y squared. Or if it says pick the quadratic, or the linear, if you see y squared, it's not any sort of function. So that's not going to be the answer. Graphically, we got a couple of ways to graph it. So like we saw above, it could open up. So it could look like that, opening up. And really it can be anywhere. So we could have it like that. That's also okay. But it could also point down. So lots of different ways, well, a couple of different ways you can see it. Now it's important to know a few names. So here's our basic shape. If you see that shape, that's called a parabola. So that shape is a parabola. And this point, that very bottom, or if it's pointing down, the very top, that point is called the vertex of the parabola. And through the vertex, we can draw a little imaginary line. And what I want to point out about that line is that the graph looks the same on the left and the right. So we call that imaginary line our axis of symmetry. And the axis of symmetry has to go through the vertex. So what I'm trying to say is, let's say if I copy that graph. So notice if I flip it, So I'm going to literally flip it over that axis of symmetry. We have the same line. So if I again flip it back, it looks the same. That's what the axis of symmetry does, is it tells me I can flip. It's like a mirror. It looks the same on both sides of that axis. All right, one more type of representation. We got the table. All right, let's fill in this table. So I've given you the x's, -2, -1, 0, 1, 2. Well, let's say the y's are 4, 1, 0, 1, 4. And you can put down a graph and you'll see that that makes a parabola. Let's see what the differences are between these. So the difference between 4 to 1, we subtracted 3 to get there. To get from 1 to 0, we subtracted 1. To get from 0 to 1, we added 1. And to get from 1 to 4, we added 3. Well, that's not a very constant pattern. Let's see if we look at this a second time, maybe we'll see a pattern. So to get from -3 to -1, we had to add 2. To get from -1 to +1, we had to add 2. And to get from +1 to +3, we had to add 2. Ah, there's a pattern. So when you look at a table, you know it's a parabola without having to graph it, because the second difference is constant. So if you look back at our notes on linear functions, we just had to do this once and we saw that it was constant. Now we have to do it twice and we see these are the same. So that means it's a parabola. All right, we're going to find the domain and the range of one example real quick. So here's my example. And I'm going to point out the vertex. It's hard to see. I tried to put the vertex at right there. So it's not the best drawing. Hopefully you can see that. So domain. So remember, domain is left to right. So going left, it looks like it goes on forever and ever, going to the left. How about going to the right? Yeah, same thing. It's going to go on forever and ever. So that means our domain is x is in the set of all real numbers. Okay, our range, remember that's up and down. Well, lowest number, that doesn't exist. You can see that both ends go on forever and ever down. But up, we stop right here. So if we go over to our y-axis, we can see it stops at 5. So that means we're going to compare y to 5. So take a moment and think, do you think y has to be greater than 5, or does it have to be less than? Well, I see this is below 5, so y has to be less than 5. And I don't see any open circles, so it could be equal to. So y is less than or equal to 5. All right, those are our notes on quadratic functions. Let me know if you have questions, and you should have some practice to get to.